Hello, my name is Lorenzo Lopez, and I am here with,
One,
and we'll be showing you how to solve the triangle BAC through oblique trig. In this case, we will be using the formulas and laws of cosine and sine. Um, in this case, we will need to first use the law of cosine because we have two sides and an angle in between. Therefore, we need to find another side in order to complete this, and later on find the two angles. Since the two sides have no corresponding angles yet, and the angle given has no corresponding side, we must first find the corresponding side for the angle we already have, which will be side A.
so the formula for the log cosine is c squared equal to a squared plus b squared minus 2ab cosine c. However, the latter does not matter in this case. The only thing that matters is that when you're trying to solve for a side, you must to have two different sides and the angle across from the side you want to solve for. So we transfer the original formula into a squared plus a squared equal b squared plus c squared minus 2bc cosine a. So the b squared equal to 40 squared, which is 196, and c squared is 16 squared, which is 256, and minus 2 times 60 times 40 times cosine A. And what we get is an interminable number. And we square root of the number 691.04 something, and we round it to decimal, which is 22.16.
Okay. Now that we've found the missing side, now we have to find the two missing angles. We already used the law of cosines, but the law of cosines is quite complex, and when it's not necessary, we really don't want to use it. So that's why we have the law of sine. But for the law of sine, you already need to know one angle and its corresponding side, or vice versa. In this case, we already have angle A and its corresponding side A. So we can use them. And usually I like to find the biggest missing angles first. And that's obviously across one of the biggest sides. So I want to find angle C because 16 is bigger than 14, obviously. So the formula would be, in this case, would be sine of A over side A is equal to sine of C over sine C. It can be written both ways, but I like to do it this way because in this case, the angles, we're looking for angles, and it's easier to find the angle if the angle is on top. But we could write it the other way around. A over sine of A equals C over sine of C. So in this case, it would be sine of 95 over 22.16 is equal to sine of C over 16. So in this case, we have to find sine of 95, divide that by 22.16, and then multiply both sides by 16 in order to take the dividing 16 from under and solve for C. So that would give us would be 0.7192 is equal to sine of C. Then we find, and obviously it's an interminable number, it keeps on going, 0.7192, blah, blah, blah. And then we have to find the inverse sine of that. And then the inverse sine of that is equal, if we round it to well, it's equal to 45.994. Keeps on going, but since it's an angle, we have to round it to 2 decimal points. It's gonna, my bad. Since it's an angle, we have to round it to 1 decimal point. It's gonna be 46.0 degrees. That will be our final answer for angle C.
As previously mentioned, we get the angle C, which is 46 degrees. Since every triangle has sin of the 180 degree, so we can use it to subtract 95 and 46, which will give us a degree is 39 degree. This is the angle B.
Now we have explained how to solve a triangle with oblique trigonometry, and I hope you guys learned how to use the law of sine and cosine, which was already described. Thank you, and have a great day.